Moving now on to the receive of the Grandstand Base Station. Well, that's not as good as I would expect on the way the volume is. So what I'm going to do is check that it's on frequency, and to do that, it's because of this strange synthesizer arrangement. The transmit and receive may be separate in the way they're developed by the synthesizer. So I'm just going to get a marker oscillator on the job, and we'll just see whether it is on frequency. Okay, right. Well, we're going to have to backtrack on the transmit because the receive is ours. Listen, can you hear the? That's the volume up. Can you hear that musical note? We need to null that by adjusting the 36.6162 mixer, which is L10. There we go, that's gone. So now what we're going to have to do is to adjust the frequency another way. We're looking at the circuit diagram. This coil here, which is part of T5, adjusts the frequency on transmit. So now I'm going to go back into transmit, which is now 100 Hz out, and we can quickly adjust it onto frequency with that. So that appears to be the transmit adjust, and that's the receive adjust. So that's one to watch. It is separate, and that can really lead to receivers being well off frequency to people who haven't realised that. Okay, so it sounds absolutely awful, and it sounds like it's off frequency, but we know it can't be because we've done that. So what we're going to have to now do is just connect the test equipment up to the receive side, to the loudspeaker, and unfortunately it's a 2-pin DIN on the on this type of radio. So I'm just going to have to get the old crocodile clip lead, because I don't have a 3.5mm jack to 2-pin DIN adapter, and we'll do it that way. What I will just hasten to add is that when you do put the receiver on frequency, make sure the clarifier on it is centralised. I can adjust that quite considerably with that clarifier knob, which of course is really a glorified Delta 2. So we're now connected to the test equipment. I think my best bet is to just see if the detector's set right. So I've put a 100 microvolt signal on it, equaling S9, and I believe the detector, now it's a funny arrangement and it's probably best done with the sweep generator, but it looks to me like the detector is the coil just there. Which I couldn't have been more wrong. L14's cleared the detector. So the coil to the right, which I think is T14, which I thought was detector, appears to be symmetry. Now it's not the normal arrangement for the FM demodulation. It's a ratio detector instead of the usual clever chip. So it isn't like they usually are. And that's why it may be best done with a sweep generator. We haven't got one on this bench, so that's the way it's done. Anyway, that now sounds super duper. The waveform looks right on my oscilloscope, and it's totally even. It's not non-sinusoidal, in other words lopsided. So now we'll go through the rest of the receiver, having got it sounding half decent. We'll switch the, that's 1 microvolt. So we'll just go through what's obviously the receiver adjustments. I'll look at my notes here, and our first receive one appears to be transformer 11. Again using the cyanide meter in the oscilloscope. So that's transformer 11. Moving over to transformer 12. Dropping off the attenuator. Adjusting 11 again. So it can be interactive. Transformer 13 appears to be the next one. The L13 there is 10.245 injection. Switching to noise blanker now on the radio, I've adjusted Transformer 8 and Transformer 9. So I'll now go back to normal. So let's look at the sensitivity. Well, that's 0.3, 0.2, 0.15, 0.1, so it's not far off the Made in Japan Amstrad, but not quite there. Right, well, having set the receiver up for best possible sensitivity, we'll now just see how the squelch performs on it. Switching the signal generator off, switching the squelch to threshold, switching the signal generator back on. See when that comes in. Oh dear, doesn't come in until 30 microvolts, which is probably about S5. Right, we're going to adjust the squelch. Now the squelch on this radio is VR3 if I remember rightly, which is the one at the back. So we'll go through that test again. Set squelch to threshold, generator off. Switch generator back on. Well, that's a bit better, but it's not good enough. So we'll back that off a bit more. We've now got it at 3 microvolts. Back it off a bit more. Squelch to threshold, generator on. Attenuator advanced, 1 microvolt, 3 microvolts, 10 microvolts. So we'll back it off a bit further. Try again. Generator off. Squelch to threshold, generator on, attenuator 1, 3. Just back it off a bit more. Generator off, squelch to threshold, generator on, and again. Right, we'll just try it in that position. I can't really get it under 2 microvolts. I've now got the control on minimum. So, I'll try again. Coming in at 1 microvolt, which is what we want. Now then, we'll advance the squelch to full. and that's coming in at 10 microvolts. So it's quite a weak squelch now, but I want it to be a sensitive squelch, so the compromise is there. I'm now going to say, of course, is we can use this in conjunction with RF gain. So having reduced the RF gain to control to half, because I need a stronger signal to overcome that. So I'm in a rural area, this radio is going to work for me with a sensitive squelch, but if you're in a town or a city, you'd need to set the squelch, which is a bit stronger than I've just done. But I've got it coming in at 1 microvolt, and that's on the minimum squelch sensitivity setting of the preset. But you may well want it to be more strong than that, because I would have to use this in conjunction with the RF gain. So that is that. We just need to do S9 on the meter. Just overlook that. And we've actually got S9 showing virtually on the meter. And it's the preset just here. We'll just adjust that. And there we have S9 on the meter. And that concludes the receive side of the Grandstand Base Station, which is now working a treat.